Welcome to bond pricing number 5. And I had been talking about the yield to maturity approach to bond pricing. And I mentioned a few times that it's far from perfect. In fact, it's pretty seriously flawed, but it is helpful. So how are bonds really priced? Well, let's start by talking about risk-free bonds, those issued by the Treasury. Okay, risk-free bonds. And by definition, they have no default risk. You'll remember that with Treasury securities, even if we pretend there's no default risk, some of the risks involved with risk-free securities are one, purchasing power risk. Purchasing power risk. And that simply means that if you have a security that's going to mature at $1,000 in 5 years, and let's just say it's a zero coupon bond that matures in 5 years at $1,000, you don't know what $1,000 purchasing power is going to be like in 5 years. As a matter of fact, by investing in that, you are trying to effectively hedge inflation that occurs over the time between the day you purchase the security and the day it matures. So, but if it matures at $1,000, you don't know what $1,000 is going to be worth then, because 5 periods down the road, you don't know for certain what inflation is going to be. So you've got purchasing power risk. Second type of risk associated with investing in Treasury securities is interest rate risk. Right? Interest rate risk. And the idea here is that if you buy a security that matures, let's say at date 0, you buy the security that matures at date 4. What if you want to sell it at date 2? What if something comes up? Life's full of surprises. Something comes up at date 2, you need to sell the security. Well, if it was going to be worth $1,000 at date 4, then it's not going to be worth $1,000 at date 2. What's it going to be worth? Well, it's going to be worth the value at date 2 of a $1,000 cash flow, which at that time is 2 periods in the future. Okay? So that's a second type of risk. And if you the idea here is if you sell a security before its maturity, then you don't know what price you're going to get. If you hold to maturity, you're going to get $1,000. You still got purchasing power risk, but you're going to get $1,000. Interest rate risk means if you sell it before maturity, you don't know what price you're going to get. But the price you are going to get is going to depend upon whatever the interest rates are come date 2, between date 2 and date 4 at that point in time. So it would be a 2-period interest rate that would be relevant then. We'll talk about that in a bit. Alrighty. So those are a couple of risks associated with risk-free securities. Risk-free is kind of a bad name. They should call them very, very low-risk securities. It's kind of like you buy a cookie that's fat-free, and I think technically in California, fat-free means less than 1/2 a gram of fat per serving, so there's still some fat there. And the same thing may very well be true with Treasury securities. We're told to think of them as risk-free, but the Treasury could default. You might say, well, the Treasury's never defaulted before. Well, maybe. As I recall, our currency used to be exchangeable, if that's a word, for gold. We used to say so right on the bills. And back in, I believe, the 70s, a lot of foreign countries were exchanging U.S. dollars for gold. And then President Richard Milhouse Nixon said, no, you can't do that. We're not going to do that anymore. So you could make an argument that the U.S. defaulted on an obligation relating to its currency back then. So if someone says, Treasury securities, are risk-free and the government would never, not hold up to its obligation under a promise, No, no. History shows that to be false. So, okay. Anyhow, enough on risk-free securities. But we'll talk about risk-free securities now. And here's how they're really priced, okay? And to understand how they're priced, we have to look back to in the 1980s. The investment banking firms then had recognized that investors liked zero coupon securities, like 1-year maturity treasury bills. They liked them a lot. No intermittent coupon payments. You pay a price at date zero, and you have a maturity value of 1,000 at, say, date one period away. Maybe it was a 3-month, maybe a 6-month, maybe a 12-month security, but investors like these. But investors would have liked and wanted to have longer maturity risk-free securities. But the government hadn't issued such things. As a matter of fact, they still don't. But some investment banking firms came up with the idea that what they would do is they would engage in something called coupon stripping. Okay, coupon stripping. And so what they would do is they would buy, say, a 60-period, 30-year treasury bond. Remember that? Let's say it has a 4% per period coupon. 40, 40, 40, all the way out to 60 when it's 40 plus the 1,000 face value, maturity value. So those are the promised cash flows of the bond. Well, what you have to do is, or what they did rather, was sell these individual coupon payments. They sold these individual coupon payments. And even the principal as individual pieces. Now, to make this example clear, we're going to pretend that we have, that we as an investment banking firm in the earlier mid-1980s, we bought, I guess the early 1980s, we bought 1,000 of these T-bonds, okay? So with that assumption, that means this is 40,000, and that's 40,000, that's 40,000, that's 40,000, and this is 1 million right here, 1,000 thousands. And well, that means if we can create, they could then create a security that had a maturity value of 1,000. For example, right here, the date 3, the 40,000, they could have 40 of these securities, and they could sell them. So what's the security? What's the security that someone could buy at date 0 that matures at date 3, making a payment of $1,000? Okay? And then here's a date 27, and there's 40,000 there. Well, they could sell 40 of these things that someone might buy at date 0, and then at date 27 would be worth $1,000. Okay? And these were very popular. Now, if investment banks are doing them, you're right if you're thinking that's not risk-free. Investment banks are quite risky investments. And that's true. So what the investment banks did was they hired trust departments of money center and banks and large commercial banks and they used the trust department of these banks. So Merrill Lynch wouldn't be the custodian of the security. Rather, they would have the trust department hold the security, and then whenever, for example, this 40,000 in interest was paid in 27, it would be paid to Merrill Lynch, but the security was held at the trust department of a of a bank, and the bank would send the money to whoever had purchased the date 27 cash flow from the bank. Again, here in this example, it's just one maturing at 1,000, but up here, we assume they had 40 of them because they did 1,000 bonds. So instead of $40, it's 40,000. Okay? Well, if you think about this, the implication of this is that when they pay a certain price at date zero, okay, so they pay, let's say they pay $980 at date zero. Well, then 980 is equal to the present value of 1,000. And instead of saying 980 equals 1,000 times the PVIF, which is 1 over 1 plus R to the n, I'll just write it. 980 equals $980 equals 1,000 divided by 1 plus R cubed. Okay, and we'll solve for R. Okay, and then we get this value for R, and we know R is the periodic interest rate for this security maturing at date 3. And then we could do the same thing here. Let's say they just say they pay 600 for it. 600 equals 1,000 divided by 1 plus, I'll just call it x. 1 plus x to the 27th power. And then you could solve for x, right? And then x would be the periodic rate that's appropriate when we look at spending 600 here at date 0 for an asset that's expected to mature at $1,000 at date 27. And we can solve for R, and we can solve for X. And these values that we're getting, if you think about it, when you here, let's look at this X. No, look at this R. This R down here is you can do the algebra. It's on my time value of money videos. Max, you okay? That's my little Yorkie in the background there. Be good, Max. All right, so you can solve for R, and R is going to end up being 1,000 divided by 980 cube root minus 1. And you'll recognize that as the formula for a geometric mean periodic return. The nth root of the price relative less 1, okay? And then if we were to calculate the yield to maturity for this zero coupon bond, okay? If we were to calculate the yield to maturity for that bond, well, my goodness, using the notation, it would just be 980 equals 1,000 divided by 1 plus y cubed. Well, here it's obvious that y is equal to r. I mean, just obvious. And so what this means is that in this example, with coupon stripping being performed by investment banks, because people would pay observable prices for securities that were very low risk, maturing at $1,000 at many, many points in time, not just 3, 6, 12 months, then you could get these periodic interest rates that were very very meaningful, okay? And they took on the name spot rates, okay, spot rates, okay? So one thing you should know about these spot rates is that spot rates, very important, you'll see why in a moment, and with these zero coupon securities, so with the zero coupon securities, okay, the promised yield to maturity is equal to the geometric mean periodic return. It's okay, Maxie, it's okay. It's okay, buddy. Okay. The promised yield to maturity of these securities is equal to their geometric mean periodic return. That ends up being a big deal. In fact, that's what gives them their name spot rates. It makes them special. And so following through with the earlier discussion of coupon stripping, you could end up with I'll call it, for spot rate, I'll call it little s, the 1 period spot rate. Then you get the 2 period spot rate, the 3 period spot rate. By the way, the 3 period spot rate is what we calculated here. Whatever that R value would be, would have been S3. And so S4 all the way out to S6. sub 60. And you could get all these spot rates. They are, again, interest rates applicable to zero coupon securities, specifically zero coupon securities which have promised yields to maturity identical to their own geometric mean periodic returns. And that's because there are only two cash flows associated with zeros. It's what you pay for it and then the maturity value, okay? Assuming you hold to maturity. Okay, so these spot rates are very important, and we're talking about a specific point in time now, and this, I'll say, vector of spot rates is known as a zero coupon yield curve. Zero coupon yield curve. And this is a zero coupon yield curve. I'll put a little superscript here, 0, effective right now. Now, please pay attention carefully to what I'm about to do. Okay. So, another way of thinking about this is as follows. So here's date 0, date 1, date 2, date 3, and date 4. And so right now, we assume investors can invest in a 1 period, zero coupon security. Oh, by the way, interesting development in the story. In 1985 or thereabouts, the federal government actually recognized how valuable these stripped coupons were, and they had been known as treasury receipts. And in 1985, the federal government decided to go and step in, and as soon as an investment bank purchased the security, as soon as after the investment bank purchased the bond, the 30-year T-bond, for example, and as soon as someone bought, say, the date 27 coupon payment, of $1,000, because it has to sell enough of them it has to purchase enough of them to be able to, to put them together in units that would have maturity values of 1,000. But anyhow, so the maturity value of 1,000 that someone could buy at date 0 that might mature 27 periods later, as soon as that person bought it from the investment bank, the treasury would put on the security that person's name as the recipient. So at date 27, the $1,000 payment would go to that person, not to Merrill Lynch. And so what the Treasury was doing, it was facilitating a risk-free, zero coupon, long-term maturity security. And they became known as treasury strips. Treasury strips. And treasury strips are the securities that I'm about to talk about, and those are the securities that are involved in this zero coupon yield curve. Okay? So treasury strips are interesting. They're risk-free, but they're not issued by the Treasury. I don't know why they don't. They just don't. Lots of things in life make no sense. And usually when it's a man-made system. I don't know if it's usual, but frequently. So these treasury strips end up being very popular investment vehicles, highly desired and very valuable in the field of finance. Okay, so treasury receipts existed. Then in 1985, the U.S. Treasury facilitated the risk-free nature of these things. Even though they don't issue them, they make them risk-free. They facilitate the risk-free nature. They became known as treasury strips, and they're very popular. Okay, and now continuing with this example here. Okay, at date 0, we assume we have some choices. We can invest in a 1-period treasury security, or at date 0 we can choose, we assume, to invest in a 2-period maturity security, or a 3-period, or a 4-period maturity treasury security. Okay? And let's just say these interest rates are 7, 8, 9, and 10% respectively per period. Tell you what, let's put a date 5 out here too. At date 0, you can also choose to invest in a 5-period maturity security. Let's say it's per period relevant rate of interest is 11%. So again, what I'm saying is the 1-period spot rate is 7%. The 2-period spot rate is 8% per period. The 3-period spot rate is 9% per period. 4-period spot rate 10% per period. 5-period spot rate 11% per period. So what this means is that whatever amount of money you invest, X dollars, let's say if you buy this security at date 5 when it matures, you'll have X times 1.11, it's 11%, to the 5th power. Okay, that's how much money you'll then have. Okay? And that's how that works. So there's a spreadsheet that is titled Yield Curves. And on that spreadsheet, you see this data that I've presented here. So I encourage you to look at that spreadsheet. And then what the spreadsheet shows you is complex versions of the following thing. We can ask ourselves, I'll do this in green. We can ask ourselves, like right here, this is someone who at date 0 bought an 8% per period security that matures at date 2. And we can ask ourselves a question. What interest rate would the person that bought this 7% security at date 0 have to earn between date 1 and date 2 so they would have just as much money as a person who at date 0 just went out and bought the 2-period maturity treasury strip? Okay? And so algebraically, we're saying that 1.08 squared, that's how much every dollar would be worth at date 2 that you invested at date 0. If at date 0 you bought the 2-period maturity treasury strip, that would be equal to 1.07. This 1.07 is the date 1 value of someone who invested for 1 period at 7%. And then I'll say 1 plus F sub 2, forward rate over the second period. And so the forward rate over the second period in this example is the interest rate someone would have to earn between date 1 and date 2 so that they have just as much money at date 2 as someone who had locked at 8% per period originally at date 0. And so this equation is important. You can see the algebraic manipulation would leave us with the following observation. The forward rate over the second period would be 1.08 squared divided by 1.07 minus 1. More generally, the forward rate over the nth period is 1 plus the end period spot rate to the nth power over 1 plus the n minus 1 period spot rate to the n minus 1 power minus 1. Okay? And that is going to be the formula for the forward rate. You can see that if you plug in 1 and 2, this becomes this. But there are more distant forward rates. And I encourage you to look at the yield curves spreadsheet in the upper left-hand corner, which does all the calculations for you. And the point of that spreadsheet is to show you that you can discern what the market thinks the zero coupon yield curve will look like 1 period in the future based upon the current values of the zero coupon yield curve and with an interest rate assumption I'm about to talk about these forward rates. This rate here would be F2. This rate here between, say, date 2 and date 3 would be F3. This would be F4. This would be F5. F sub 5. All right. And the idea is that we could then build I'll put it in a different color so you can see. I'll put this in brown. Okay, that we could see the zero coupon yield curve that would be relevant at date 1, at least expected as of date 0. So here in a little graphic, here's the 0, 1, 2, 3, 4, 5, and here's what you just saw. Okay, and then I'll change the color and I'll put in the forward rates. And so what I'm now saying, change the color. What I'm now saying is that we can build another zero coupon yield curve. The one that as of date 0 is expected to be in existence at date 1. And it might look like this. Here's the 1 period spot rate at that time that is expected as of now, 2 period spot rate, 3 period spot rate, 4 period spot rate. And then also, also we can get an estimate for the zero coupon yield curve expected to be in existence at date 2. So it would be, just graphically showing this, this, and this. And we could find the one expected to be in existence at date 3. And that would look like this. And the one at date 4 would be kind of, I guess, interesting. It would just look like this. And so I encourage you to look at the yield curves spreadsheet that I sent you. It'll show you the calculations of these expected future zero coupon yield curves that are all derivable from knowing what the current zero coupon yield curves, S sub 1, S sub 2, etc. are now. Okay? And look at that a bit. I know you get this in other classes, but it's important that you spend some time wrestling with this. Okay. So now here's kind of the biggie. Once we have the zero coupon yield curve, we have very, very meaningful and important periodic rates of interest for risk-free securities. And so if we have a 4-period maturity, for example, treasury security, okay, with a coupon rate of, say, 6% per period, remember, our periods, for the purposes of this course, are every time a coupon payment occurs. So in the real world, they tend to have coupon payments for coupon-bearing bonds twice a year. Our periods, then, you can think of as being 6 months. But the coupon rate I'm giving you is already per period. The world would call this a 12% coupon bond annual, even though that's not correct. That's what the world would call it. But we're going to be precise and call it a 6% coupon rate per period. So we got to, by assumption of 4-period maturity treasury security, the promised cash flows of this are 60 at date 1, 60 at date 2, 60 at day 3 and 4, plus 1,000 at date 60. Okay? And what I'm telling you is that the real price of this bond, the real price in an efficient market of this bond, will be as follows. The price of the bond at, say, date 0 will be 60 divided by 1 plus the 1-period spot rate, plus this 60 divided by 1 plus the 2-period spot rate square, plus this 60 divided by 1 plus 3-period spot rate cubed, plus that cash flow, 1,060, divided by 1 plus the 4-period spot rate to the 4th power. And the point here is that a 4-period spot rate is a risk-free rate that's applicable to all risk-free cash flows occurring at date 4. And in our example, those are the risk-free cash flows occurring at date 4. And so what I've shown you here is this is how risk-free bonds are really priced? Risk-free bonds are priced off the zero coupon yield curve, okay? Depending upon the values for the spot rates, S1, S2, S3, and S4, okay? Now, after you calculate this value, so this is going to give us some number, okay? Here's how yields to maturity come into play, okay? So this is some number. So now there's that number, whatever that is, and we set that number equal to this. Say 60 divided by 1 plus y, plus 60 divided by 1 plus y squared, plus 60 divided by 1 plus y cubed, plus 1060 divided by 1 plus y to the fourth power. And then we quote solve this, okay? And then we get a value for y, okay? And that y value is the yield to maturity for the bond. That y value is the yield to maturity for the bond. And so now you can see that it is clear that yield to maturity is just a plug number. It's just a plug number. What do you mean by that? Well, it is just the yield to maturity is just the value of y that causes this side of the equation to equal this number. And that number was the real price of the bond, where this risk-free bond had each of its cash flows discounted at the appropriate, unique to it spot rate based upon when the cash flows occur. That's all for now. Thanks for watching.